Yes.
Okay. Share. Okay. Okay, so last week we talked about using Pandas for data analysis. So this week I'll just briefly explain a few more things. Basically, I've written the code in such a way that it's self-explanatory, so it will be easy for you to follow. Just some more functions and what you can possibly do. So the last one, we used data we got from Kaggle. Now you can, so basically you can always download any data set you want to do any form of analysis. So for today, I'll just show you a few things that you can do with data from either anywhere or data you probably enter manually. So typically, as you understand, you import your libraries. And this one, okay. Let me do this. So this is just to display the data so that we can see all of them instead of just printing the head or the tail of the data. I guess by now you're already familiar with, this is a Markdown cell. Okay, so so let's assume you have data of this format, right? Let's say you want to create a data of this format. Let me run the code first so you can see. So let's say you want to create data of in this format. We have columns for month, category, and amount. It could be anything, basically. This is just fictitious data I just created, right? So setting months, that's for a number of entries, month, category, and amount. The way to create this kind of a data using Pandas, remember we import Pandas as PDs, and we import an alias of that .data frame. Then if you remember when we talked about dictionaries, right, the kind of data structure. So this is similar to that, but in this case, you have like a key. In this case, the keys will be month, category, and amount. Then we're going to be passing like a list through it. That list is what we have as January, like this repeatedly. And that's what we have. So for the month, the number of entries, like this category, the same number of entries, then amount. So basically, as I explained, the month or category amount, it is a series. A combination of this series is what they call data frame. So if you verify that by checking the type, that's type, and put this in. And let me see, that's in that. Okay, it's supposed to be this line. So if you verify that, you see that this is a data frame, which is a combination of series of months, category, and amounts. This is something we've done before, but the new thing about this is that I've not shown you how you can create your own data, right? So for you to use Pandas effectively, you have to create a data frame, and how to create that is by having like a key and a key which correspond to a list of variables of values. Then another thing you can do with this is you can sum up the value, the entries in a column, right? So for that, we already have an instance of this, which is this Excel. This Excel.amp. You can call it anything basically. That's just what I called mine, right? So if you look at this data, month and category, they are categorical data, but amount is numerical data, it's numbers, right? So of course you cannot sum this, or you can sum the amount. So to do that, that's whatever you decide to call it, Excel.ample, then square brackets, then the name of the column .sum. So I'll explain how this sum, we've used some of these before, right? They are functions, which will be what I will explain much later. So .sum equals to, now you have to specify the axis. For rows or column, it's either 0 or 1. I will explain that briefly, right? So if you run this, it sums up all the entries all the entries under amount. So if you look at this 78, if you add all of these entries up to 120, this is what it gives you. So this is the code to do that. Simply the data, you specify the column .sum. Then you specify the axis, then that's what happens with that. So let me see now. Okay, so for pivoting, if you're familiar with Excel, you probably have learned how to use pivoting. Let me just run this and show you what happens. So, okay, let's do this. So, okay, so if you look at it, this is the original data, right? We have columns of series of months, category, and amount. With pivoting helps. It's just a way of manipulating your data. You can switch rows to column, or you can index by a particular column, just depending on the way you want it. So this is the original. This is the data itself, the one we created. This is the one we created, right? So we have it's been indexed by. We can create a pivot from this, or a pivot table from this. Basically, let's index it by month. Then the columns will remain the categories, but then by the value, and see what happens and how it changes. Okay, oh, I've already run it here. Okay, basically, yeah. So if you look at this, you can see that instead of it sorts them by month, in the sense that instead of having multiple January, February, March here, it sorts it like this, right? You see that by month. So the month now becomes the index. Then under the month, we have that's the other categories, right? The entertainment, grocery, household, transportation, depending on that, based on what we had written in the data, these entries. So this just gives you a different representation of the data, which could make it a lot more easier for analysis. So instead of having, you see, this data is a bit complex to analyze because we have a lot of repeated values. But if we pivot with a different entry, like with months, it becomes easy to visualize and analyze. Then one common analysis you can do, you can probably find the sum of either a column or a row. And simply remember the original data is this, right? Then dot pivots. So one thing is if you type out the data dot tab pivot, you get these entries. Then you select them basically. So I'll share this, then you can play with it and see how that works in essence. So you can also find the sum of entries for for either the column or the rows. For this one, so we can find the sum of the rows, right? So which is the data dot sum equals to the axis. For rows, it's 0, and this should be column. For column, it's 1, right? So if you specify axis equals to 0, it's with Python is usually, I think most programming language usually rows before column. So axis equals to 0, row equals to, column equals to 1. So with this, you get the sum of all the entries. So if you look at it, for entertainment, we can say the total is this, but if you add all that, it corresponds to this, right? You can do the same thing for the columns by just changing the axis equals to 1. And if you run that, you get, you see, so for the column, if you remember, this is being indexed by the month, so it will give you according to the rows, right? So that's what we've got in basically. This D type is just the data type. It's trying to tell you that this data type is under float 64. That's 4 type. That's the object. Are there any questions? Okay. So pivoting basically is just rearranging your data to make it more interpretable for better analysis, right? So this is another sample of a data frame I've created. I won't spend too much time on this, but you can just run it as well too. So if I run that and I print that, you see the way I entered the values, that we have like a key and a list and entries, right? That's, let's say, another one, an entry. So it's like fair, that maybe amount paid for something, maybe the position in the class or something, sex, then it's survived or so. I just got this from somewhere, so I wrote the code like that. So if you run this data frame, it prints out this data. So you can do that for any kind of data you want, or if you're entering it basically. Remember, it's been indexed, so you always have an extra like column here. So if you want, as we have done previously, you want to index this by let's say the position. What's the chart? No, no, this is not the same one from last week. So this data is, I'm just one who wrote this. This is just like sample data. The one from last week was Uber data, which I got from Kagula. So this is just sample data, basically. I'm just showing what you can also do as well. I could as well do it with any data. So yeah, so if similar to what we've done previously, we can do the same thing with this, right? We index by, let's say, the position in the class, run this, and if you look at it, you see the male and the female, that's position 1, 2, and 3, which is here. That comes to the rows, and then the values it means what we appear under those columns, right? So the columns, the sex, which is the male and the female, the index, which is that's the position in the class, which becomes 1, 2, and 3, which becomes the rows. Then the value, which is the fair, is what you have here. So you can do this for any data. Actually, I think I'll do that with the Uber data and send it to you guys and show you how. I mean, it's the same thing actually. It's the same procedure and everything. That didn't come to my mind. So this is still the same. I think this is the same thing, but this time we're indexing with the values that survived variable. So that's that. I think so for this Titanic data set, I think that's what I sent this during the week. So if you have it in your working directory, you can just run that. You can run that. So it prints out, .head prints out the first 5 rows. So this, then we can then do some, then we can then index it, right? But if you use, by combining lock and passing this list through it, if you do that. So these are just different ways to probably analyze your data and everything. I guess they are self-explanatory. So I'll give you the notebook, you just run it through, study what happens through, and that should be that. I don't spend too much time, so because functions are also very important. Let's see. I think this is the same thing too. Okay, so if you want, okay, I think this is how to, let's see. Yeah, you can also find maybe find functions, or calculate some specific function, like the maximum of a certain row or column, and you need to pass in this argument, argfont, right? That's actually the only thing that's changed from what you've been doing previously for this one. You can also count the number of values under a specific column, which is this as well too. Okay, cross. Okay, yeah, you can just cross that too. So basically, this is just the same thing. So using the melt function is like, so you're trying to spread out the data, make a flatter representation of the data, right? So if you have like your data frame dot pivot table, index, and everything, so you can reset. If you reset the index, this makes it flat. Let's see how that works. Okay, pivoted. And you can see, compared to this one, you see this is a flatter representation of okay, the only difference here is the fact that yeah, let me see, okay. Yeah, the only difference here is because we're trying, instead of counting, we use crosstab, but this is a flatter representation of the data itself. So let's see, melt. Like .melt, just makes it flat, exactly. Just, you see this other one is like it flips the axis. Just flips them. I think that's basically that. Let me see. We've done this. So okay, yeah, let me just explain stacking. So stacking data, like you're putting, you're arranging data on top of each other, right? You're arranging maybe a slice of data from one data to another. So look at this. Let's see. So yeah, if you have like a series A and series B, you can stack it to C, or you can unstack it by removing that. That's what this command does. And that's what the code here explains. So you can concatenate series A and B, or you can A and B and C. You can remove a particular one too. Like, let me see, like this. Why did it go up? It should be down. I don't know why that is. So, but this you can unstack by remove. This will take away column C from that. It takes this off away. You take that away. Then you can reset the index. If you reset by setting name, right? Then it returns back to what you had originally. So let me see. I think basically they're just kind of self-explanatory. If you have any questions, you can probably ask about that, and I'll explain that basically. So I'll share this when we're done with the class. Any questions about that? I think answers so okay, I'll explain functions, but there's something I didn't explain. It was about commenting code. So typically, if you're commenting your code, you need just that. There are two ways to do that, basically, right? With the hash key, it comments a line of code. But if you have multiple lines, you probably want. If you have multiple lines, you don't just want to keep doing that for all of the lines, right? You use doc strings, right? So use doc strings, and how that works is just shift double quote 1, 2, 3. So this comments the code. I don't know if I was too fast. Let me explain that again. So shift double quote 1, 2, 3. Enter. That comments the code. What's that? Not a question, but we share. Yes, I will share that, right? Yeah, I don't want to explain the function because I think it's very important in explain. That's why I guess you probably don't understand certain things I do. But I will share that much later. If you have any questions, you can ask me privately. It's basically the one I just explained briefly is based on what you had done previously. So if you've not done the previous one, probably might be difficult getting what I just done. But yeah, I can explain much later if you have any questions. So in commenting code, you can use doc string, for a line of code, right? So comments block. So if I run this, you see, I mean, it basically doesn't obstruct any code, right? It will still probably print out something because there's no code in that. So if I do this, let's see, for instance, it just prints out 4. It doesn't see every other thing I've written. So you can comment code by using hash or doc strings. By doc strings, I explained just, I don't know if it's universal. When I mean universal, I don't know if the command is the same, but what you need to do is just by shift that double quote 1, 2, 3, then enter. Oh, sorry, let's see. So shift 1, 2, 3, enter. Oh, enter. Okay. Yeah. So anything you write in between here like this, it doesn't see it, right? So even if you do any computation below, so 4, 6, it only computes that, and everything here is commented. So that's that. If you also need to comment something quickly, you can use if you type anything, let's just say random stuff, right? Control / and that comments it. That's so control / that does that. Okay. So typically if you have if you need to perform different operations, either with strings or numerals or numbers or calculations, basically, especially functions or operations you have to do very often. A good practice is always to write functions, right? For instance, if we are to do this, let's say for instance we have to do okay, write it this way, 2, 3. So let's say we are to add the first 2 numbers and subtract the third one. This plus this. Right. We've just done it for the first time. And let's say we are to do this for another let's say for 6, 8, and 3, right? It's simply 6 plus 8 plus 3. Right. So we have to do this kind of operations repeatedly, and for very similar cases, right? Let's see this. Okay. You can't keep, especially when it's the same kind of operation. There's no point repeating the same thing because the operation is the same. So what a good practice is to use functions. So with functions, functions are for, you are going to write a block of code that you're going to be using often that helps you do the same thing repeatedly. It's basically for abstraction and reusability, right? That's one use of functions. Another thing is, if you need to copy codes that have to do the same thing repeatedly, copying codes could induce errors, because if you copy the same block of code and there's an error in the first line or in a particular code, that error is going to propagate. It will repeat itself in many places in your code. But if you have the same code in one place, if you correct that particular line of code, or you don't need to go and correct it in other places, with that line of code, when that line of code being corrected, you can easily effect that change. And also for ease of, that's for, to make your code readable, like production code, typically you have to use a lot of functions. So I'll explain that briefly. Let's, so this, I'm going to write a function now. You probably may not understand what I'm doing, but before the end of the class, you understand this function. Second, let's see. So if you look at this first expression, right, we had three numbers, 2, 3, and 5. I just performed an operation by adding the first one, taking the third one from it. The same thing I've done with the function here. So now I'm going to repeat the same. I'm going to do that for all this, and let me show you how that is done. Don't worry if you don't understand what I've written. You understand before we are done. By the time we are done with the class. So what I've just done is this. So look at these operations. I'd simply, let's say I'm always giving it three. I'm giving three numbers, right? And I need to simply add the first two and take the third one from the sum. I could do that by each cell, doing that individually. But I could write a function that all I need to do is just to enter those numbers, and the function will do that, right? So that function is this line of code, really, which is this. That is this, right? So all I need to do is, instead of simply doing it manually, I just call that function and input, and add those numbers will become an input to that. Then you see, as I just did that, the code prints this all out, right? So with a function, I don't need to keep adding numbers separately. I don't need to keep doing the same operation separately. All I need to do is to call the function name and impute the numbers, right? So that's how a function works. So I'm going to now explain the basics of how the structure of this function for you to understand. So basically, functions are a block of code. They're just a block of code, that you probably need to use often. So that the block of code that you need to use often, basically. And there are two types. We have it's called built-in functions. That's the ones that come originally with Python, right? Or with Anaconda. They are pre-installed. And we have a user-defined function. That's the one you define to do anything you want to do. So the code, this one I've just written, is a user-defined function. because I'm the one who specified what I wanted, right? So I'm going to explain. So we've actually been using some of the built-in functions, probably we didn't notice. For instance, a function, so this is the structure of a function, basically. Name of the function, then arguments, right? That's just basically the structure of a function. It has a name, and that's for a built-in function, right? We have a name and an argument with that. For instance, if we have, okay. If you can still remember, let's say this, let's create a list. Orange to Paris 3. So this is a list, right? This is a list we've just created. Now if you remember, there are some functions we've used before. For instance, we can find the type of this function, type X. So this type bracket X is called a function. If you look at this, right, the name of the function is in front, name, which is this. Then the argument, that's what your own input to give the result is the argument, which is X. So our input is a list. So we are putting a list into this function called type to know what type it is. So if you run this, it should tell us that this is a list. So this is basically the structure of a function. So we've been using this before actually, but I didn't explain to you that it was a function. So a function, basically, this is a built-in function in the sense that these functions are native to Python. They're already there. You don't need to define what they need to do, right? So for instance, another function is, let's see, different examples. So this, we've used this before. So it's the length. This is length of the list, length of the values in the list, right? So if you look at this 1, 2, 3, that's why it prints length 3, right? If you type print also is a function. It's an inbuilt function, right? Print X. So if you look at the structure clearly, we have the name, print, argument. That's your own input, which is this. So these are built-in functions. Now, Python has a lot of built-in functions. There are very many actually. So let me show you how you can check the list. You don't need to, of course, there's no way you can memorize them, but from time to time, as you use Python very often, you know how to use this. You know how to use most of the built-in functions. I think it's built. I think so. Yeah. So if you want to know all the inbuilt functions, that's the functions are native to Python. This is the way to do that. This is the code to do that. Let me just write that. So I just this is also an inbuilt. This is an inbuilt library. Import built-ins, then directory of this, right? So if you scroll down, right, this is the first one. There are very many actually. With time, you get to know how to use them. Let's for the familiar ones, the ones we've already used, like directory. I think we just use that here, right? Let's see, type length, right? You see that's here. List. You can also list maximum of a value of a list. You can also list that out. So these are all inbuilt functions, basically. Tuple type, the one we just used. So this is how to see the inbuilt functions. With time, you get to know how to use each and every one of them. I've never used some of them personally, right? But if you're not sure, you can simply just copy the name, then Google it and probably add Stack Overflow, then you see how to use them. So these are basically built-in functions. These are functions that are native to Python, that they're already with Python, right? So all you need to do is just just write out the type bracket and put in your argument, and it gives you, then it do what it's been designed to do. You can also create your function like the one we have done previously. Now, in creating your function, this is something you're actually going to use very well in everything you do, right? if you are doing, I mean, if it's any data, so any work that has to do with data science or even machine learning, basically. Let me write this. Okay. So the structure is it's similar, but it's kind of different too. So this is the structure of how the user-defined function looks like. Let me copy that function and written. Let's copy this. And compare it to what I've just written, you see that it's very similar. Let's comment this first. So this is structure basically. So you have to first you are defining that's the name of the function and the argument. That's the inputs to the function you are defining or you are creating, right? So this is it. So if you notice, you see some variables in green. These are native Python words or keywords. You don't use these words for you don't name a variable with these words, right? Python will throw up an error. So these are native to Python. So this I think it's definition. I'm not exactly sure about this. So the name of this function, you determine the name of the function. I decided to call it a calculator. You can call it anything you want, but just make it something you can remember that relates to what you are doing. Call it calculator. Then my arguments are my inputs. I want to write a function that takes 3 numbers as input, adds the first 2 and subtracts from the third, which is this. So the first is 1, second is the second number, the third is the third number. Then all this will be in brackets. That's the input. Then that will be a colon, right? Then when you press this, that's when you type enter. If you notice, there's a space, right? So one thing with Python is Python. I think it's you have to respect these spaces. Basically, some other programming languages you can get away with it, but with Python, it has to be indented. Yeah, that's indentation. That's the right word. It has to be indented. So if you notice, when you okay, let me do that. If I press tab, anything I want to type, you see it automatically falls under that column. If you type anything here, it's not going to work, right? So it will all be, so anything that falls under this is part of that function, it's within that function. So then what I'm writing, as I'm defining my function, what I'm saying it should do is this. When you enter the first value, right, take that first value, add it to the second, and subtract from the third. Then store all that as answer, as a variable answer. Then return answer as the output of my user-defined function. That's what this does. So if you notice previously, you're just simply adding 2 plus 3 and taking 5 from that manually, right? But with this function, once you write this function, you can use it anywhere within this script, or even in other scripts by calling the right function, by referencing or evoking, you evoke functions, basically. We call functions or evoke functions. So like this one, for instance. So when you write your function, the next thing you do is to evoke the function or call it, which is this. You do that by the name of the function, which is calculator, then the inputs 2, 3, and 5. Then we assign it to X, right? So if you run this, let me see. Sorry. Okay. I get it. So this, yeah, okay. I was running, this is a code cell. So this will show up as an error because, yeah, okay. This will show up as an error because this is, I mean, this is not Python code, it's just syntax. So this is the function itself. Then this is how to call the function, right? The name of the function, which we defined already as calculator, then the inputs. So when we run this, you see it simply does the same thing. So for any other problem, you just type, all you need to keep doing is this calculator, and the numbers you want, even if it's a negative, you just enter, right? And then output y. So if you just do that, output y, it gives you the value. So for any case, you just change the values you want, right? So if you now want to make a change to this function, all you need to do is to come here and make the changes instead of running sequentially to all the problems you have solved. So this is the basic structure of a user-defined function, and you can do that for basically any problem or anything we've discussed previously. I hope that's clear, really. So, so that's the first. So that's the first thing about functions. Then with these functions, if you have to respect the position, right? So if you look at the, okay, let me think of a better way to explain that. Okay, yeah. So for instance, if you define any variable, right, you have to respect, for instance, if a number you want it to be first, since you've already defined you define it in the function as first, then it has to be that first number. That's the way it's going to work. But if you want, there's a different way around that, which is key. It's called key, what's it called? Key argument. So let me just write that. Let me modify this to show you how that works. Let's see this. You understand the difference when I'm done writing this. So, okay. 3, 6, third. So, okay, the difference with this and the first, okay, let me just give this a header to make it clear. Plus, so the difference between this and the first one is this, right? So for a function, you can decide to specify the value you want, right? It doesn't mean you can overwrite it by the time you are calling the function. But what this does is that you can then flip the order. In the sense that you don't need to respect the order anymore. For instance, this function defined the first, you wrote the first, second, and third respectively, like that, right? But in calling this function now to do something different, if you notice, I started with the second equal to 3, and Python works that way because it has recognized that this has already been assigned values. So I could still simply, I can still simply call these same values, and I could still call these exact values and to work that way. But if I want to change the order, I'm free to, because we are now the variables are defined by values itself. But for this one, I have to just follow it exactly. I think let me just try and write an example to make it also more clear. Okay, if we do this here, this 3. Let's see. Second is not there. Okay. Yeah. So I need to define that. That's 3. What if you didn't assign any value in the function? That's if I didn't pass an argument. You can also write functions that way, but that is, you can also write functions that way. Actually, I'll get to that. You can also write functions that way without passing an argument, but there must be a reason for doing that, right? It's not usually productive doing that, right? So let's see. Okay, result 3. So let's see. Okay, so like as I saw just now, if I didn't pass, if I just written, let's say first equals to 6, it throws up an error. That's what I just noticed, right? Let's see. Yeah, it shows up an error basically. So you have to, so if you are assigning variables to it, if you are assigning variables, then you must, if you are assigning variables, then you can flip the order. But once you've written the code, once you've written the function assigning variables, then you must continue doing that when calling it. I think that's what just happened here. I didn't even notice that before. So if you're assigning variables, like, so I think it depends on what you want to do, but personally, I prefer always doing this, right? Just as the arguments without the variables. But the thing is that sometimes too, you're probably not sure of maybe the order. You might want to do certain things, especially when you're looping through a large data base or something like that, right? So if you define this first, then you must continue to call it by, the arguments must be referred by with a variable, and you must assign a value to that, like we've just seen here, basically. I don't know if that answers the question. Okay. So basically, so with functions, you can really do many things, right? Let me think of, let's see, for, so, so if you look at it, the structure, it remains the same, right? You define the function, the name of the function, I'm calling mine print underscore info. Then the arguments, what it means that for you to use this function, you have to specify a name and specify the age, right? Then then the colon, then you press enter, you see it indents under print, like that. You can write print, let's see. If you want to type anything, it has to be in string, right? Let's see, sorry. Is let's see, out to market string dash that is let's see, command is see return. This function is slightly different from what I've written, but I think it's the same. It's print. So you print tab is so let's see 3 let's see. Okay, so what I've just done is this, right? I've defined, actually it's good to always comment your code. So define function. So I've defined the function, then here calling the function or evoking the function. So what I've done is this, defined as the Python keyword is in green. The name of the function, I'm calling my print underscore info. Then I want it to take as input a name and age, right? Then colon, enter, it indents it, print. Then what I'm saying is that anytime somebody enters the name or age with this function, it should print this. Now, I don't know if I've explained this before, but you don't, of course, you don't write text the way you write text. It has to be in quotation marks, right? So my name is, then it prints this name that you entered, it will print this name here. This name is assigned to a variable, so you don't put quotation marks with it. I'll answer the question. Let me be done explaining this. So you don't put quotation marks with this, right? You don't put quotation marks with this, right? Then name. Then if you, okay, so basically what you need to do anytime you are typing anything you want to appear as you want it, you bring quotation marks. Outside that, like name and age, no quotation marks. That's why you can see them in black. They're separate, right? So if I do that, then return. That's return is like to end the function. Because without return, the function doesn't print an output. Return semicolon. Let me see. Okay, I'll explain why I need to do that here. So semicolon. Then if I'm done with the function, I can call it, right? The name of the function print info, which is this, the input. So if you notice, I'm calling, instead of write echoes, I mean, it will still work if I type name first, but because I have assigned this age to a number or to a value, right? I can decide to call age at, at any position. So age 33, then name. That I could do that because I already done this, right? So so by running this, it just prints out, you see, my name is, this one's in quotation, which I enter Peter. Let me see. It's supposed to be, okay, yeah. Input is, I'm thinking of something. So yeah, okay, I'll explain that. So basically, that's how it just works. All you need to do is call the function and it does that for any value you want, right? Here is 55. It just prints out basically all what you've done. So you just call the function with the name and the input variables. That works that way. Any question? Okay, yeah, somebody asked a question. I don't know. I think it's private message, but let me just see. Value, try to give value. No, so the thing is, if you didn't specify this age as, okay, let's just do that. If we don't specify this and we run this, I don't think this should work. I might be wrong, but I don't think it will work. It does. Let me see. Oh, it does work actually. Okay. Okay, I saw that message. Anyways, let me see. Name. Well, I don't know why this. I'm surprised that worked actually. Let me see. Let me try this. Okay. Well, I think if you specify actually, I'm surprised this worked because I specified the age with the value and it still worked. But what I was thinking was that if you have the name, if you don't specify name and age, you have to respect this, the sequence, right? Name first before age. But this worked actually. But anyways, if it works, that's fine. That's also good as well. Any questions about that? Yeah, I can see something. Let me see. Oh, I see. Okay, okay. Fair enough. I was thinking it doesn't work that way. Okay, yeah, that's fine. Because I mean, I tried before. Probably it worked. Okay, that's fine. If it works that way, that's good as well. So let me show this. So if you write down, let's say function kids. So sometimes you can, okay, let me probably write. Class, let's see, kids. So anytime you write a function, you have to, for you to use that function, you have to leave the, I mean, you have to, okay, let me do it. If I press enter, you see it's still on, it's indented under print, right? For you to use this function, you have to leave the function itself. So my function is, let's see. So I'm trying to show you how you can use more you can specify just one input, but you can specify just one input, but use more than one. You can specify just one argument, but use more than one, and it will still work if you use the asterisk, which I'm showing here. Let's see. So this is another function we just defined, right? So this function, I'm calling it my function. That's my underscore function. Now I'm just having one argument, but if you notice, I'm having just one argument. But when I'm calling my function, I entered more than one, right? That's because of this asterisk I added in front of this. So by using the asterisk in front of this, you can actually use more than one argument. Right, I think it doesn't. I think it's if you check Python documentation, I think this is how it's usually specified, right? You can use more than one argument for it. So I'm saying for my inputs to this argument, what I should do is I should type the youngest child. The youngest child is. Now, if you look at this, so for this kid, kids, right? That's my input. Instead of so what I'm trying to input here is more like a list, right? Is a list, and in this list, I'm specifying in the sense that if you look at this list, we have John, Peter, and Susan, right? So in the list, if you look at Python, we start from 0, 1. So Peter is 1. That's why it's C kids, then square bracket 1. That's why it prints out the youngest child is Peter because of this square bracket 1, right? So I just, in as much as I fed it with more than one, but I then instructed that, okay, pick just one variable, right? If I change this to 2, it should turn to Susan, right? With 0, it should be John. So that's another way you can use functions, basically. Just one argument, but with this asterisk in front of it, you can allow us to pass a list through that. I hope that's clear. Let me see. Let me just edit this instead of writing a fresh code. There are many options too. You can also use double asterisks without this. So, same thing, but this time let's use something like last name. Full stop. Oops. So that's the first name. And last name. Somebody asked a question. Yeah, I'll explain what double asterisk is. Let me just write the code first and be sure what I'm trying to do. I'll explain what that is. Let me see. Okay. So if the number of keyword arguments is unknown, right? So for this one, I think let me see. Remember this one. It's KW something like keyword. I think something like this. So for this one, right, if the number of arguments is unknown, then we use the asterisk in front of the input. Now for this one, if the number of key arguments is unknown, the key arguments, there's a difference, right? then you use double asterisk. For instance, look at this. We are saying the same, it's almost the same thing actually. The youngest child is, we have kids there, but we are not indexing by referring to with a number or so, right? We're just indexing by the last name, which I'm going to specify when it's typing in the input. So if you need to specify an input, but you're not exactly sure what that will be, then you use double asterisk. But for this one, let me just write it here. So, so for this one. So this is the number of arguments. Okay, number of arguments is unknown. That's it. The specific number, you don't know it, then you can use this. But for this one, if the number of keyword arguments, okay, use double asterisk. So if you're probably going to pass in an input, but you're not exactly sure what that is, this allows for flexibility, right? You can write maybe many lines of code that will be doing different things, but you're not exactly sure if you probably need to pass in maybe a string or something like, yeah, most likely a string or something like that, right? You can specify with double asterisk. So with double asterisk, it's flexible, because if you don't specify this, you throw up an error. But with this, you see, I just, for the function, the first name, I just gave this. I gave this and the last name. Even if I don't need this, without this, you just write the youngest child is this last name, because I've already specified this in a code, right? So that the way it works. This one, arguments, the number of arguments, it can be as many as you want, as long as you want the asterisk is there. This one, the key arguments must be specified, basically. So you can also pass a list through a function. Let's do that. Let's see. Functions are actually very robust. You can do many things with them. That's why in all programming languages, you have, everyone uses a function, right? Okay, let me just write this, but I've not explained how to use for loops, but maybe next week. X, I think. So then define a list. And if we call this, right, this, it should work, okay. Okay. Wait, let me show I understand your question. Isn't this supposed to be food or not food? Let me see. Wait, let me explain this first. Probably I'll get to understand your question. So for a function, so I've just defined a function here, right? So this function, the name of the function is, I call it my function basically. Then the argument is, okay, I get your question. The argument, that's the input, right? Which is the argument is food, right? So I'm not saying, so what I've just written here for X in this is called a for loop. I'll explain for loops next week. That way you understand that, but just for the purpose of making something clear to you, I'll just explain. So what I'm saying is, from when I put in what do you call it? Okay. Once I send an input can be anything basically. If I send an input, we're going to iterate over that input. So let's say the input is food, right? So for X in, that's like a counter. I'll explain for loops later, but so for every of the values or items in that list, print the value, right? Now, if you notice, yes, you said the input here, I wrote food here, but I'm using fruits here. That's because I'm just, this food, I mean, if you just say food is, to Python, food is just a word, right? It doesn't know what it is, right? So even if I call this, okay, let me do that. If I call this food, It shouldn't make any difference. Right? When I run the code, it's still the same thing, right? It doesn't make any difference because this is just a word. A word, I mean, it's just a variable to itself. It's what you define it that it will be, right? So even if I call this, I have just called this true, that you see it still works that way. So this input, it only takes on the value you've assigned it to. Or if it's a string, then it's totally different. Or if it's a numeral or a number, right? It's different. So for this function, what I just said is, if I pass in a list, like this food is a list, right? Square brackets, remember, it's a list. And I said for every value in this, for every of the entries, like items or everything inside, like the apples or oranges and berries, just print it out. Just print what is inside. That's what it has done. It goes in and prints apples, oranges, and berries. Let me do that with a number, with something numerical. Probably that will make more sense. Let's do this. So, 3, 4. X. So let's define another function. My function, let's say pass x straight. Then we say for every value in this function, multiply by 5. Right, so let's see. Print my function market x. Okay, I guess why I did that. Return. Okay. Return. Yeah, this correct, but I want it to multiply the entries 1 by 1. Let's see, 2, 3. Okay. Let's see. Oh, it sees it's a global variable, so it sees it, right? So for I in x, do this, let's see. I don't know, I'm trying to get it to do something, but I'm seeing it's doing something else. Let's see. Okay. No, it's right, actually. Okay, so like this, I've just passed in a list, right? And for the list, I'm saying it should iterate. That's for every value there, you print that you're going to repeat this, return the 5 times of that, which it does that for all of this. What I actually want, okay, let me change this. Okay, I think I know what I was thinking of. Let's put this. This is 6. We comment this. Okay, so if you let's say you have a value, a variable like x, right? Okay, let me define this out behind. So we specify the value. So we just said the first one I passed a list, right? So this time we are passing just a value, or that's a variable. So you say for this variable, multiply it by a particular number, right? So if you pass that into this, you score that with this function, it multiplies anything you pass by 5 to give you 30. So that's why when I did that, it returns 30 as the value, as the value basically. So you can still pass in a list as well too. If you pass in a list, let's do that. Let me comment this. It returns this in multiples of 5 times. No worries. So by the time I pass this in, that's a list, right? It returns this 5 times basically. So you can decide to pass in a list or a specific value. I hope that's clear. I think we're almost done for today. Yes. So the last thing I want to explain is how to, so if you have any questions, just ask. But the last thing I want to explain is how to use functions from another script. So you can always write functions. Let me open this. See. Not sure. So you can, so another thing is that you can have functions from maybe written in a different file, and you can call that function in another file, right? So for instance, this is, of course, we are working in this is the notebook we are using, but I have some functions already written here. So this function can help you count the number of vowels in a sentence. And that this first function, right? This is this. Another function here is to simply check if a number is even or odd. Why didn't 5 multiply each number? Okay, I'm coming out. I'll explain that. So you can check. So these files are in a different. These files are in a different notebook, right? You see, this notebook is called utility_functions. It's separate, but it's in the same working directory here as the one we are using, which is somewhere here. Where is that? I don't know. Well, it's just in the same working directory, somewhere here. I think, yeah, one of these. Yeah, okay, functions somewhere here, right? So if this is the notebook, so if we are here, right? If we want to use the function in that notebook, what we need to do is, if you type this command, run, that's %run, that's run, then space, then you type the name of that notebook. Activity, I think if you press tab it. Okay, so just by typing run, %run, then the name of the notebook, you see it's kind of, by pressing tab, to search that directory, which is my working directory, and it shows this, right? So if I run this, it shows now that I can access the functions that are there. So if you notice on this script, you've not written any function about, any function else apart from adding and subtraction. But let's say I write this, print vowels, what's count, I think. So what I've just done is I've written, so, okay, this is a separate script. It has its own functions. But sometimes if you put all of this in one script, it will be very bulky, right? I think if the name of the argument is different from X to return. Sorry, I'm coming. I'll look at your question. Let me just explain this. I'll look at what you're writing. So I have functions in a different script, right? Of course, most times, if you put all of this in a particular script, it will be bulky and might also be difficult to follow. So I think typical industrial practice is by putting all your functions in a particular script and calling them from the current script. So I'm here. So to call that, all I need to do is percentage, or this percent, right? Or percent run, then the name of the script, right? Then if I now type a function, like for instance, this script I have here, what it does is it prints, if you type a word, it can count the number of vowels in them, right? That's A, E, I, O, U. That's what it does, basically. So if I come here, all I need to do is, instead of writing the whole script and the whole function. Yeah, like I'm calling it from this script by writing print vowel count. That is the name of the function there. Then this is my own input argument. How many vowels do we have in this word? And it prints out 11. So you can always refer to any script, any file you have, any function you have in another script by just calling that. So for this one, it's like a script to check if X is even or odd, right? So for this one, let's see. You can also run that from here because we already have, because we have access to the functions there already. So if I type, if you type any number, just, that's not numbers. If you type any number, you run that, it tells you even, because all it does is that since you've written this command, it references that and runs this script. So that's how to use functions. So if you're writing, maybe you're doing lots of work, right? You don't want to have one script that will be very long with all functions. You can get confused. You put all your functions in a particular file, right? Then you reference that here. So I think, so this command is native to Jupyter Notebook. If you're using something like Spider, you need to do from, or that, yeah, different. I think for depending on the ID, you probably need to do something different. You need to do from this script, import asterisk, then you have access to all those files. Okay. Any questions? So yeah, let me see what's in the chat. I think the name of the argument is different from X. I think if the name of, okay, yes, right. I think, okay, for this one. Is it what you mean? Let me see it again. I think if the name of the argument is different from X to return. Oh, so I'm not sure, I'm not sure I understand what you mean really. Do you mean X here or no? Because this X has to match this, right? It still returns 2, 5 times. Yeah, actually, I'm not sure. I actually want you to multiply every entry inside, right? You can also use a for loop, but this should work. So that's what I'm wondering. Yeah, probably figured that out. I don't know why that is. See, for I this. Anyways, any question? So that's basically all for today, really. That's all for today. Yeah, I think yeah, for loop works basically, but I'm also wondering why this should not work. Because for loop, for if you say for I equals to, or for that's for I in this, then this. Let me just try it. Let's see, Y star X turn 5 times this. I'm not sure why this is. I probably figured that out. I'm not sure why this is. We should go in and multiply all, but it's counting. I think it's. Or it doesn't identify X as a list. I see. But why is a list right? Yeah, it's supposed to. That's why I'm surprised too. But the for language video argument. Yeah, let me see. Is it because I'm using X here? No, but it shouldn't matter, right? But let's see if I use for and, so, okay. But this then prints out. Okay, no, but this is just a number, right? So y, but this is just, let me see. For I number, return this. Okay, sorry, I don't want to make a mistake. No, let me see. Is that for I in X? I mean, that's technically what this is, right? Let me see, return this times this. Because for the, let's say the number is y. Because anything you define, like this number, you can replace it. It just shows that if you have y here, anywhere you see y, then it becomes this number here. So it's 5 times this. I don't know, I'll figure it out, but it's supposed to, I expect to give like 10, 15, 20 right here. Don't know why that's the case, but yeah, so any questions? I mean, I think we're done for today. What if the list is defined before? It shouldn't matter, right? I think as long as if the list is defined before the function, it shouldn't matter really. It doesn't matter per se. I mean, anywhere, but as long as the values are unique, I think sometimes I'm probably calling, let me see, still returns 10 for I in this. Does this work? I don't think so. I don't know. Let me just try it. Yeah, it doesn't. Why is, yeah, this cannot be interpreted as a variable. This will only work if, let's say here, 10. Times 5. Print. So, yeah, range works, right? I'll figure it out. I probably think I'm missing something, right? So, I mean, I expect it not, instead of duplicating the number of values I mean the list itself, it should go in and multiply. I'll figure that out and explain, maybe share it next week or so. Yeah, this one for I, this works, is basic. Okay, still seeing value of y from where? Maybe there's y defined somewhere. Sometimes too, I think we have conflict of variables, so it's defined somewhere. Okay, yeah, I think that's all for now. Any other questions? Yeah, no worries. Bye.